To all my students and pupils, good morning. We're here now to discuss to you our new lesson for this week. Mr. Ronel De Vera, your science teacher. Our new lesson for this week is all about the sun, the facts and layers of the sun. Let us discuss first the facts about the sun. The sun is 4.6 billion years of age, 4.603 to be exact. The sun is a star made up of hydrogen and helium. And also, it is located at the center of the solar system and the largest object. Next, the size of the sun. The sun is an average size star and largest object in the solar system, gaya nga ng sabi ko kanina. Millions of Earth could fit inside the sun. Ibig sabihin po nun, sa laki ng sun, million of Earth size could fit inside the sun. So, ganun po kalaki ang sun. The sun looks larger than the other stars that can be seen in the night sky because it is much closer to Earth. Ibig sabihin po, ang araw po is nakikita ng mas malaki kaysa sa ibang stars na nakikita natin sa gabi. And to our naked eye, in space, the sun would appear white, not yellow. Okay, nakikita po natin ang kulay ng araw ay puti, hindi po yellow. 6 to 10 billions of part of the sun is gold, and the Earth's core is about as hot as the sun. Pluto takes 248 years to orbit the sun. Okay, isa sa mga dating planeta sa ating solar system ay ang Pluto, na ngayon hindi na sa sobrang layo niya. Pero ang Pluto daw ay it revolves the sun, and it takes 248 years bago po makumpleto ang isang complete revolution. Okay, next, as passengers on Earth, okay, we are all carried around the sun at a mean velocity of 66,600 or 107,182 km per hour. Ganun po kabilis ang kumbaga takbo natin o ikot natin dahil habang tayo ay kumbaga belong sa solar system. So the sun is 400 times further away from Earth than the moon is. Ang araw daw po ay mas malayo ng 400 times kaysa sa ating moon. All of the world's energy needs can be met with 1 out of 10,000 of the light from the sun that falls on Earth each day. Ibig sabihin po nun, so kahit sa 10,000 na binibigay ng sun na light sa ating mundo ay kahit isa lamang po doon ay kailangan ng ating mundo. And every day, plants convert sunlight into energy at equivalent po nun ay 6 na beses the entire power consumption of the human civilization. Every day po yun. The star that's closest to our sun is Proxima Centauri. It is still much farther away than Pluto. Pinakamalapit daw na star sa ating araw ay tinatawag na Proxima Centauri. Pero ito po daw ay mas malayo kaysa sa Pluto. Next, a bolt of lightning is 5 times hotter than the surface of the sun. Okay, and if the sun were the size of beach ball in space, or yung ganun kalaki sa volleyball, then Jupiter would be the size of golf ball, and the Earth would be as small as pea. Okay, so kung matatandaan ninyo, ang pinakamalaki na planeta sa solar system ay ang Jupiter. Okay, but the largest object in the solar system is the sun. So, doon sa tatlo, mas maliit ang ating planeta. Okay? Kung susumain po natin. Ganun po kaliit kung titignan po natin tong tatlong to sa solar system. Okay, that's the end of our part 1. the facts about the sun. Okay? And next, we will be tackle the part 2, which is the layers of the sun or the structure of the sun. Okay, in our part 2, we are going to discuss about the layers of the sun or the structures of the sun. So, there are two layers of the sun, inner layer and outer layer. So, under inner layer, we have core, radiactive zone, and convection zone. While the outer layer is composed of photosphere, chromosphere, and the corona. Let us discuss first the inner layer of the sun. Deep inside the sun is the innermost layer, which is the core, na parang isang napakalaking nuclear factory na may 195,000 miles na kapal, na para muna ring nilakbay or tinravel ang LA to New York ng 70 times. And most of the energy that sun produces is formed in its core. The core's temperature is 10 million to 10 million degrees Celsius. Ganun po katindi ang temperatura sa sun's core. And then, the pressure is more than 1 billion times greater than the air pressure of Earth. Okay, kung gaano katindi ang air pressure dito sa Earth, ay 1 billion po ng ilang beses na mas malakas, matindi sa core. Next layer po natin sa ating inner layer is radiactive. Next to the core, moves the energy produced in the core in every direction. It can take millions of years for energy to move out of this layer. So, ano pong nangyayari sa zone na to or dito sa layer na to? So, yung energy po na nanggagaling sa core ay siyempre dumadaan po muna dito sa radiactive. And then, so sa kapal or sa dense, okay, na pressure meron po din po dito sa radiactive ay hindi po agad-agad basta-basta nakakalabas ang energy na nagmula sa core, papalabas po totally dito sa layer na to. Okay? Pero sabi nga nila, it can take million of years of energy to move out of this layer. Pero hindi, ibig sabihin po nun, yung hindi naman, walang antay pang 1,000,000 taon bago makalabas ang kahit ni isang energy. Hindi po. Ibig sabihin po nun, yung totally lahat. Okay? Million of years ang aantayin bago lahat ng energy na yun na nandoon sa layer na yun ay makaalis or makalabas ng radiactive zone. Our last and third layer is the convection. This layer is next to the radiactive layer. Ang nangyayari po dito ay those gases with different energies move in circles in a way similar to air with different densities. And those energy moves out of this layer in about a week. 1 linggo bago po ito makalabas totally. Okay? Tulad po nito. Okay? Ito po yung explanation ng process ng inner layer. So, ito po yung tinatawag po nating core. Okay? The hottest part of the or layer of the sun. Okay? And this part is the radioactive. So, when the core producing energy, okay, yun po. So, that energy, kailangan po niyang lumabas. Yun po yung purpose ng energy. Yun din po yung, kumbaga, binibigay ng sun sa object sa solar system, especially sa ating mundo. So, yung araw na yan, yun po yung energy na kung saan papalabas. Okay? So, that energy, kumbaga, kinukonvert niya yan into EMR or electromagnetic radiation, better known as light. Okay po. Okay? And this part is the tinatawag po natin convection. Okay? Sabi natin kanina, those gases, ibalik po natin. Gases with different energies move in circles. Okay? Ito po yun. Okay? Kung titignan nyo po, kumbaga opposite. So, parang entrance and exit po yan. Kailangan po silang, kumbaga, hindi pwedeng magbanggaan. Okay? Para po sila ay makalabas. Pero it takes 1 week bago po makalabas ang energy na yan. Okay? Doon po sa layer na convection. Question: what happens inside the sun? So, bakit po nakakapag-produce ito ng energy? At sino po ang may sala? So, the hydrogen particles smash together to make helium. Yun po yung tinatawag po nating nuclear fusion. When the hydrogen is smashing the helium, a little bit of it is lost when hydrogen particles combine to make helium. Okay? Yun po yung nagiging energy na napuproduce o pinuproduce po ng ating core. Okay? The mass in turn into energy. Yung mass while the hydrogen is smashing the helium turn into energy. And we see this energy as light and heat. Okay po. So, yun na po yung nakikita natin na light at nararamdaman po nating heat na nagmumula po sa sun. Okay? So, yun yung nangyayari inside the sun. Okay, next is outer layer of the sun. Okay, nandito na po tayo sa outer layer of the sun. So, the first layer for our outer layer of the sun is photosphere. So, it is the visible surface of the sun. When say visible, yung po nakikita po natin na surface ng sun. Yun po yung photosphere. It is not a solid surface, but rather a layer of gases. Just like the earth, okay, pag sinabi po nating surface, so visible surface of the earth, yun po yung ground. Pag sinabi natin ground, solid po yan, solid surface. Pero pagdating po sa sun, okay, that visible surface, okay, na nakikita po natin sa araw, ay hindi po siya solid, kundi a layer of gases. And it is cooler than the core with a temperature of 10,346 Fahrenheit. So, mas malamig po ito kesa sa core. Next is the chromosphere. Our next layer for our outer layer is the chromosphere. Okay, so this layer is the inner layer of the sun's atmosphere. Opo, tama po yung narinig nyo. Maski po ang araw ay mayroon din pong atmosphere, hindi lang po lahat ng planet. So, in this layer, the inner layer of the sun's atmosphere, when it can be seen, it looks like a red circle around the sun. Pero hindi po yun po yung photosphere. Kasi po yung photosphere, yun po yung visible surface. Hindi nga lang siya solid. Okay? Composed of layers of gases. Pero ito, kumbaga ito po yung, pag sabi nating atmosphere, parang pagdating sa ating planet, yun po yung nakikita nating may clouds, ganun. Okay, the last layer for our outer layer is the corona, the outermost layer of the sun's atmosphere. The corona takes on the different shapes around the sun depending on changes in the temperature of the photosphere. Okay po. Yun po yung sa outer layer. The photosphere, which is the visible surface of the sun, from the word itself, photo. Okay? Yung napipicture po natin na nakikita natin sa sun. Okay? Yun po yung photosphere, the visible surface of the sun. And the chromosphere, which is the inner layer, atmosphere of the sun, and the corona. Ito po yung corona. Kaya tinawag po siyang corona kasi pa siya nakapalibot. Okay? Pag nagdo-drawing po tayo ng sun, yun po yung sun rays. Okay, yung sun rays po. Yun po yung parang tinatawag po nating corona. Okay, so the structure of the sun, ito po yung summary po ng ating layers of the sun, the inner and the outer layer or layers. Okay, let us now summarize our part 2, which is the layers of the sun. So in this part, the inner layers, and this part is the outer layers. Okay, so let us read and discuss. So the core, which is the hottest part of the hottest layer, I should say, of the sun, where nuclear fusion occurs. So pag sabi ng nuclear fusion, dun po yung yun yung process na kung saan nagko-combine yung hydrogen and helium. Okay, and then napuproduce po ng energy. and that energy converts into light and heat. So, yung radiation and convection, parang yun lamang po yung exit ng energy na na-produce sa core. Okay? And then, dito po sa photosphere, which is the visible surface of the sun. Okay po? Pero hindi nga walang siya solid. Okay? It composed of gases. Next layer for outer layer is the chromosphere, which is the inner layer of sun's atmosphere. Okay? And the corona, the uppermost part of the atmosphere and millions of miles thick. Okay? And then, bago-bago po siya ng shape. Kasi nga po, yun po yung parang sinag ng yun po yung sinag ng ating sun. Some parts of the sun. Okay, kung nakikita nyo po yan, yun po yung tinatawag po nating solar flares. Solar flares are bursts of heat and energy that stretch out from the corona and chromosphere into space. So, ibig sabihin daw po, yung solar flare sa isang, or mga bursts of energy, heat and energy, na nanggaling sa chromosphere and sa corona. Okay. Next, so, pamilyar kayo siguro sa ganyang pangyayari sa ating atmosphere. Yun po yung tinatawag po nating Aurora Borealis. Ulitin ko po, Aurora Borealis. Aurora Borealis is also called the Northern Lights. And then, that Aurora Borealis has energy. Okay? Energy from the solar flares. Nanggaling daw po yung Aurora Borealis na yan sa solar flares. Also, causes displays of different colored lights in the upper atmosphere. Mostly, nakikita natin yan sa Alaska, Canada, and Northern United States or US. Sunspots. When you say sunspots, they are dark spots of the sun. From the word itself, sunspots. They are dark spots of the sun. From the word itself, spots. Okay, yun po yung mga itim-itim na nakikita natin sa ating araw. Then, meron tayong tinatawag na umbra and penumbra. Yung mas darker is umbra and yung medyo light is the penumbra. And those pores na tinatawag, yun po yung mga maliliit na itim o spots sa ating araw. Okay? So, that is our lesson for this week. So, thank you. And then, you study hard. Just ask me any question, this PM or personal message para po masagot ko kung ano ba po yung mga tanong. Thank you so much. God bless. Keep safe.
Deep inside of the sun is the innermost layer, the core, which is a gigantic nuclear factory 195,000 miles thick. That's the equivalent of driving from New York to Los Angeles 70 times. In this most mysterious layer, the crushing pressure feels 150 times stronger than being deep underwater. Pressure and density are so great in the core that hydrogen atoms smash into each other, combining to form helium. Now atoms become highly unstable and release nuclear energy to become stable once again. We call this process nuclear fusion, and it's the very process that keeps the sun and all stars alive. Every single bit of energy that leaves the sun and reaches Earth originated from the core. The core is the sun's hottest layer. How hot? 27 million degrees Fahrenheit. That's hot enough to instantly melt lead, iron, brass, or any other metal. Just above the core lies the radiative zone. Now, the nuclear energy generated in the sun's core travels through the radiative zone in the form of electromagnetic radiation, better known as light. Density slightly decreases, but is still tremendous. The radiative zone is 186,000 miles across. And ironically, this is how far light can travel in 1 second. However, the radiative zone is still so dense that photons of light bounce around like a pinball machine. In fact, light takes around 100,000 years just to make its way through the radiative zone of the sun. Finally, we reach the convection zone, which spans for around 124,000 miles. Now density finally becomes low enough for light traveling out of the core to transform into heat. And just like this layer's name, the process of convection kicks in. Simply put, convection means hotter materials will rise, cooler materials sink. And as the heat from the bottom of the convection zone rises, it gradually cools, sinking back down again. This continual process happens in gigantic bubbles known as convection cells. Convection is also the same process that causes the big bubbles in a boiling pot of water. Well, the Sun is an extremely complex main sequence type G2V star. Whatever that means. Even the most brilliant minds and NASA don't completely understand that. But learning about the Sun's layers and the basics of what they do is pretty simple. Let's start with the outer layers. Did you know that the Sun has an atmosphere like Earth? Pretty cool, huh? The outermost layer of the Sun is called the corona, which is Latin for crown. Surprisingly, this outer layer is one of the hottest at around 2 million degrees Fahrenheit. That's not cool. At these temperatures, atoms like hydrogen are stripped of their electrons, leaving only a bare nucleus. The Sun's magnetic field lines trap hot plasma and form spike-like shapes, called streamers. These are what give this layer its crown-like appearance and name. The corona also causes the northern lights here on Earth. As plasma flows out of this layer into space, it eventually hits the Earth atmosphere and interacts with atoms and molecules. And these reactions cause the beautiful colors that we see. The next 3,000 miles is the Sun's chromosphere, which is Greek for color sphere. Now the temperature suddenly drops to around 36,000 degrees Fahrenheit. And at these temperatures, hydrogen atoms begin to radiate in a reddish color, hence the layer's name. But against the brighter background layers, you can only see the chromosphere and the corona with special, expensive equipment. However, once in a while, we get a rare look from Earth at both of these layers during a solar eclipse, like the one in 2017. The moon temporarily blocks the much brighter layers, allowing us to see the corona and the chromosphere. Finally, we reach the photosphere, which is Greek for light sphere. This is the layer of the Sun that we're all most familiar with because it's where visible light first appears on the Sun. And now temperatures fall to a nice chilly 6 to 11,000 degrees Fahrenheit. The photosphere is also where we see sunspots, which are randomly appearing dark spots that are around 3,600 degrees cooler than the rest of the layer. You've probably seen pictures of the photosphere whether you knew it or not. It's covered in a granular-like pattern, kind of like skin. This pattern is the result of wild convection processes happening in the layers inside the Sun. So now you know what the layers of the Sun's atmosphere are, and a little bit about how they work.